Okay, this is the DSP kit that we have got that we are going to use for the experiments in the DSP course. The name of the kit is DSK 6713 that you can see on the top left of the kit. This kit mainly has 4 input and output connectors. These are the audio jacks, so you can actually connect a mic and then you can connect a speaker to this kit, and these are these general purpose input output connections that you can use to take the input to the DSP kit and do the processing and give the output. Then this is the black one. This is the 5-volt power supply where you connect the power supply. Then you have the USB cable where you can connect the USB cable to program this kit. Then you have the dip switches that you can use to control some functionality of the kit. These are the 4 LEDs. This is the reset switch and some other connections, some other buttons that you can use to control different portions of the or different functionality of the kit. So we are going to use this kit for the experiments in our DSP course. First, today we are going to look at 2 programs. The first one will be Hello World. So as we have already seen how to install Code Composer on the system, so in this lab what we are going to do is see how the Hello World program runs on this DSP kit. So we'll establish a connection, real-time connection with DSP kit and run that program. The second thing that we are going to do is control these LEDs by using our program. So first we are going to do is write a program that can actually blink any one of these LEDs. Then what we are going to do is use these dip switches to actually control these LEDs. So we'll turn on this switch to see if we can turn on this LED, and that is one of the very basic things that we can do. In the future labs, what we are going to do is actually we'll use these audio connectors as an input to take the input from the mic and give the output to the speaker and do some signal processing on that audio signal. So the first thing that we are going to do is power up this DSP kit, and when we power up this DSP kit, you'll see some of the LEDs will turn on. And what we got to do is this has automatically got a self-test program which will blink these LEDs, and after some time these LEDs will settle down. So you can see these LEDs are blinking and now they have settled down. If these LEDs settle down, that means everything is okay. So this is just a self-test program on this kit. If the LEDs do not settle down, then that means that there is some issue with this kit and we need to figure out what is the problem. So for our case, the LEDs have settled down and the kit is very stable, so that means we can go ahead and start programming this kit. Just to show you that if we reset this kit, so by resetting this kit, this will automatically start these LEDs blinking once again, which will run the self-test once again, and after some time these LEDs will settle down. They will start blinking in a few seconds and then they will settle down to a stable position. That shows me that DSP kit is absolutely fine and it is ready to be programmed. So when this LEDs settle down, next thing that we are going to do is we're going to connect the USB cable with this kit, so that we can start burning our program onto this kit. So this is the USB cable that we are going to use. So it comes with this DSP kit and it goes over here. So you must have heard the ding on my computer. So that means this USB kit is connected to my computer and I can go on Code Composer to start writing my program. So we are going to start our first program. We already know that how to install the Code Composer on our machine. So we have done that. So what I'm going to do is start a new program. First of all, I'll just show you a very quick Hello World program, so that just to see the things are running, and then I'm going to run this program create a new project and run the whole program on my machine. So first thing that I do is right click on that and clean the project, so that the previously built executable will get deleted, and then I'm going to rebuild the whole project. So this should run fine. It is giving me a couple of warnings which are okay. They're not a big deal. Let's go ahead and start the execute the program. So what it will do is that I've enabled the debugging mode. So what that does is automatically tries to connect with this device, and when it has connected with this device, it is going to pause the program at a certain position. And as you can see on my screen, it has paused over here. If I want to put a breakpoint, I can simply double click on the screen. It will put a breakpoint over here. If I don't want to put a breakpoint, I can just double click on that. It will remove the breakpoint. The next thing I have to do is resume the code and see if it runs the hello world, and tells me on the console that it has been able to communicate with this device and run the hello world program. And that is good for me to go, so I can stop this program. Okay, I'm happy with this one, so I'll go ahead and I'll run the LED program. As you can see, it's again very much similar to C++ programming, and I'll show you some of the codes that I've already written. So these are some of the examples that come with the with this DSP kit. So all that I need to do is I need to tell that this is the kit that I have, which is DSK 6713, and I want to initialize that. I want to initialize the LEDs. I want to initialize the dip switches. Because what I want to do is I want to be able to control these LEDs using these dip switches. So all that I'm going to do is I'm going to run this program, which is LED toggle, and the LED that I'm going to tell it to toggle is LED 0. So it has 4 LEDs. So I'm going to toggle the 0th LED, 0, 1, 2, 3. So if I change this number to, let's say 2, it's going to toggle the LED number 2. Then what I'm going to do is I'm going to check on my dip switches if the dip switch number 3 is actually equal to 0. If it is 0, that means it is pushed down. It is going to turn on the LED number 3. So 0, 1, 2, 3. So this is going to turn on the LED number 3. Otherwise, if I turn it off, if I pull the dip switch up, it is going to turn off the LED. So let's go ahead and run our program. Of course, what I'm going to do is first I'll show you the ready program, and then I'm going to compile and write the code right in front of you so that you know exactly how you are going to compile this program on a DSP kit. And you'll see that every time I'm going to compile, I'll hit a hurdle, in which what I'll have to do is I'll have to fix those problems in the program, and then I'll show you on every step that how I'm going to fix these hurdles. So let's go ahead and run this program. Rebuild this project. So everything is building fine. It is giving me few errors on the build, which is okay. Let's go ahead and run this program. Okay, so what that should allow you to do is let's take the video of this portion. Let me start the program, and there we go. Let's put a breakpoint over here. There we go. Then I can start executing this. I can see the recording. Okay, this. There we go. And I can see my LED which is blinking. This is the LED number 0. You can see, you might be able to see on the bottom the number which is written here, which is LED number 0. Then I have programmed this dip switch number 3, this 0, 1, 2, and 3 to control this LED. Let's see if I can control this. Yes, I can. So by pushing it down, this turns on. If I push it back, pull it back up, this LED goes off. Okay, so I have done two things. First of all, I have programmed this LED to keep on blinking after half a second. So after every half second, so what this program does is it toggles the LED. So if it is 0, it turns it to 1. If it is 1, it turns it down to 0. And then the other portion of the program, I've controlled this LED using this switch. So when I turn it on, here we go, this LED turns on. When I turn it off, this LED goes off. Okay. to the recording. Okay, I had to remove this. There we go, and I can see my LED which is blinking. This is the LED number 0. You might be able to see on the bottom the number which is written here, which is LED number 0. Then I had programmed this dip switch number 3, this 0, 1, 2 and 3 to control this LED. So let's see if I can actually control this one. Yes, I can. So by pushing it down, this turns on. If I push it back, pull it back up, this LED goes off. Okay, so I have done two things. First of all, I have programmed this LED to keep on blinking after half a second. So after every half second, so what this program does is it toggles the LED. So if it is 0, it turns it to 1. If it is 1, it turns it down to 0. And then I have the other portion of the program, I have controlled this LED using this switch. So when I turn it on, here we go, this LED turns on. When I turn it off, this LED goes off. Okay.